Hi everybody. I just want to give a brief video for you today about section 8-4, angles of elevation and depression. The good news is this really doesn't use any new math that we haven't used before. Mainly it's just applications, word problems. One thing to be aware of though is the definitions of what it means to be an angle of elevation. Right, just right there, going up, and an angle of depression. Okay, that's the only thing you really need to watch out for. So looking at the textbook, what's an angle of elevation? Well, it says an angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the line. So it's like this situation right here. You have this horizontal line right here. Right? And it's the angle formed from that horizontal line and a line of sight above it. So you're going from that horizontal line up. Angle of depression is just the other way around. It's an angle formed for a horizontal line. Okay, that's the dashed line right there. And a line of sight to a point below the line. So here's a horizontal line, and we're going down from there, right, to a point below it. So let's look at one of the problems, a word problem, and put this into practice. The math, again, is identical. We're just going to be using a trig function. So let's look at problem number 15. So number 15 reads, so a forest ranger is in a 120-foot observation tower, and he's seeing a fire. Okay, so I already drew the tower out here, so it's right there, up and down, and it's 120 feet. Okay. The angle of the depression to the fire is 3.5 degrees. What is the horizontal distance between the tower and the fire? Round to the nearest foot. Well, okay. All right. So whenever you're drawing these problems, I think it's important to kind of draw out a situation that looks kind of like this. Okay. So you need to create your horizontal lines. Right? So you can properly identify where to put your angle. So that's what I did here. I got two horizontal lines, one of them right there, one of them right there. Okay? And what I'm forming here is a right triangle. Okay? So I have the towers right here. I have the distance from the top of the tower to the fire there. And then I have the distance from the tower horizontally to the fire, from the bottom of the tower to the fire right here, all right? And that's actually what the question is looking for. Okay, so now we just got to put the angle in the right spot. So it says the angle of depression to the fire is 3.5 degrees. Okay, now that's an angle of depression, okay? Which means you do not put it right here. That is not, that angle right there, that corner of the triangle, is not 3.5. The angle actually needs to go right here, right? There's your 3.5 degrees, okay? And that means, because we're dealing with parallel lines here, well, alternate angles, well, that means this guy right here also is 3.5 degrees, okay? So now that you actually have it drawn, it's actually a pretty easy problem. It's just what we've been doing in the past two sections. I'm just going to take a look. Well, I want to find x. I have this side, and I have that angle. Okay, well, looking at this angle, what sides do I have? This side right here, that 120 feet, is opposite to it. That x is adjacent to it. Well, okay, what trig function uses opposite and adjacent? Well, that's the tangent function. So let's use that. So I have the tangent of 3.5 degrees is equal to, well, it's opposite over adjacent, so that's 120 over x. Okay, this is not too bad. So I'm just going to multiply both sides by x and divide by the tangent of 3.5. So I'm just going to rearrange this thing to get x is equal to 120 over the tangent of 3.5 degrees. And you can just do this on your calculator. You should get approximately, when you do the math, assuming your calculator is in degree mode, you should get 1,962 feet. Okay, and that's it. Same problems we've been doing before. The hard part is just, being able to draw this picture so you know what exactly to find and putting the angle in the right spot. Okay, that's it for today. Thank you very much.